Good afternoon, everyone. This is LadyDragon speaking. It is now Tuesday, January 21st. It's 1:55 p.m. Now we're going to go to another keynote presentation. Well, this one is with Facebook and Wing Capital. And it's called, this keynote thingy thing is called The Era of AI is Here. So, let's see what they have to say. Enjoy. Là, on s'en va regarder un autre keynote. Ça a rapport avec le AI là, de Facebook puis de Wing Capital. Fait qu'on écoute ça. Here we go.
Good morning. Well, we are privileged to have with us today one of the three godfathers of artificial intelligence. He is the recipient of the Turing Award, as well as many other awards that I wouldn't be able to list here. He serves as Chief AI Scientist at Meta. Everybody please join me in welcoming Yann LeCun to CES. So, Yann, in preparation for this session, I asked quite a number of humans and non-humans for questions for you. I've got two pages of questions. We'll get through as many as we can. Let's start with the news of the week. Sam Altman from OpenAI earlier this week blog posted that, and let me make sure I get the words correctly, we know how to build AGI, and we are beginning to turn to superintelligence. Now, you have had kind of choice words for AGI and for 2025 predictions. What's your reactions and thoughts?
Well, first of all, that really depends what you mean by AGI. I don't like the phrase, frankly, because people use it to essentially designate intelligence that is at the level of human intelligence. And human intelligence is very specialized. We think we have general intelligence, but we don't. We're super specialized. So the whole phrase, AGI, in my opinion, is nonsense. But now, if we are talking about human-level intelligence, what do we mean by this? Do we need being able to, pass the bar exam or entrance exam in college? And the problem is we can't measure this because for every single task that we can come up with or every benchmark, we're going to be able to build a specialized system that beats that benchmark. And over the years, by assembling all those systems, we'll have systems that can do a lot of things. But that doesn't mean they have human-level intelligence. That doesn't mean that they have the capacity to plan, reason, solve problems, understand the physical world, all that stuff. So
how will you know whether or not Llama or subsequent models have gotten to human-level intelligence, which is the phrase that I believe you prefer?
So there is absolutely no way in hell, pardon my French, that autoregressive LLMs of the type that we know today will reach human-level intelligence. It's just not going to happen. Okay? So I don't know what Sam was referring to, what type of architecture he was referring to. He didn't say.
Yeah.
In the past, he said, we are thousands of days from AGI, whatever you mean by that. I would agree with this. It's thousands of days. The question is how many thousands? Just 1,000 is 3 years. So we're at least 3 years away, but it's more than that. If the plan that we're working on at Meta, at FAIR, succeeds, because we also have some idea of how to get to human-level intelligence. If everything succeeds and we don't, hit any obstacle, I don't see this happening before 5 or 6 years.
So I don't want to spend too much time on definitions because it's kind of an eye-rolling exercise. But when Sam and OpenAI talk about AGI, so I looked this up, on the website, it's highly autonomous system that outperforms humans in most economically valuable work. And obviously for human-level intelligence, looked it up too, just to make sure, an AI system that can accomplish all the intellectual tasks a human can accomplish with similar performance. So there's differences, work versus tasks, all versus most. But Yann, what Sam talks about as AGI and what you talk about human level, are we generally in the same ballpark, or are these just vastly different things?
Vastly different. So, there are tasks that are purely intellectual, that, with sufficient amount of training data and maybe, a new type of architecture we might get to in a relatively short amount of time. And then there are tasks like, human tasks that a lot of humans can accomplish, like plumbing. We're not going to have an automated plumber anytime soon. It's incredibly complicated. You know, it requires a very deep understanding of the physical world and manipulation and everything. And it's not because we can't build a robot. It's just that we can't get them to be smart enough to really handle the physical world. In fact, we're not even close to matching the understanding of the physical world of any animal, a cat or a dog. I mean, they have a much better understanding of the physical world than any AI system that we have today.
So when Sam says that we know how to build AGI, let's stick with his definition for the moment. And sort of, do you believe that definition of AGI is achievable, given that your definition is vastly different than his?
Well, I think
is his achievable in 2025?
I think it's a terrible definition. So, I mean, I don't think it makes sense. You know, it's like everybody who comes up with benchmarks for human level intelligence and say, like, you know, if you succeed in this benchmark, then you'll have achieved human level intelligence. And people have kept making the same mistakes for 70 years now, okay, almost 70 years, where, you know, back in the 50s, you know, one of the first AI programs by Newell and Simon, you know, pioneers of AI, they very modestly called it the general problem solver because they thought this program could solve every problem. And in principle, it could. In practice, it couldn't. And it was based on search and things like that. And, you know, and people in AI have been making that mistake all the time. Also saying, okay, we have systems now that can beat us at chess, so pretty soon, you know, they'll be as smart as we are. We have systems now that can drive a car through the desert. Pretty soon, we'll have self-driving cars, you know, level 5. We still don't have them, you know, 13 years later. You know, pretty soon we'll have, you know, systems that can answer any question. And we're getting closer to this, but we're still far. Like, you know, as long as the question we ask, like, obeys a template that isn't a training set, yeah, you know, LLMs will answer it. You change the statement a little bit, and they don't have common sense. Like, notion of common sense, like, when are we going to have machines that have common sense? That's an important question. And you're not going to get this without understanding the physical world.
Sticking back to the current for a moment, so I hear you that autoregressive LLMs will not get to human level intelligence. Back to the current sort of, if you would, next 2 or 3 years, there's a lot of discussion on scaling laws and whether or not scaling laws have slowed for LLMs, and also whether or not the new test time compute models reinstate scaling. What's your view on whether or not these test time compute models are a whole new scaling within the family of LLMs?
Okay, so yes, scaling is saturating. The exponential curve that we were experiencing over the last few years is now become a sigmoid. Every exponential curve turns into a sigmoid at some point, at least in the real world. And the cost of training bigger and bigger LLM on more and more data is growing pretty much exponentially. The performance is not increasing, you know, in the sort of related scaling laws. So we're not going to get there by just scaling, right? There were people who were claiming a few years ago, who have not changed their mind, by the way, that it was just a matter of scaling to get to human level intelligence. It's clearly not the case, and now more and more people, I mean, I've been saying that is not the case for a long time. Now, the thing I've been advocating for a long time is planning and reasoning. And what does that mean? It means and I've been talking about this for the better part of the last 8 years now. What does that mean? It means having systems that have some mental model of the world that allows them to predict the consequences of their actions and then plan a sequence of actions that will satisfy a particular objective. Okay? This is not a new idea. In fact, it's very classical in optimal control and robotics. It's called motion planning or model predictive control. And now people in sort of the LLM area are kind of rediscovering this, and they call this, you know, inference time search. But it's really a very classical idea in both good old-fashioned AI as well as engineering disciplines like optimal control. You don't compute the output of the system by just running through a bunch of layers of a neural net. You optimize your answer. You search for an answer that satisfies a particular objective.
So are O3 and Gemini 2.0 flash thinking, are they, in your mind, brand new and continued scaling for LLMs?
So they are doing search, but they are doing search in token space. So in the space of words, basically, right? So basically, if you have and the idea again is very old and it's been used within the context of deep learning and in a game playing system like AlphaGo, AlphaZero, and the equivalent from various other players. So basically, you have the system generate lots and lots of sequences of words or outputs, whatever they are, moves for a game, okay? And then you have a way of basically only generating the ones that are promising, and then you have a second neural net of some kind that rates which ones are the best and then selects the best, okay? It's very expensive because you have to do this search through basically an exponentially growing number of sequences. So it's incredibly expensive. In fact, right now it's not economically practical, right? Which is why OpenAI is charging $200 a month for that service and not making money with it, so.
I guess the reason I'm spending a few minutes in this is that there's a big discussion maybe 3-4 months ago that scaling is dead.
Yeah.
You had Ilya talk about the era of pre-training is over. And then with O3, there was a lot of excitement that test time compute is the new scaling path. And you've got folks, I believe if I got this correctly, Jensen and others pushing back on kind of the scaling kind of question. Maybe here's one way to think about it, Jan. So let's put a metric to it. Let's say there was 1 unit of improvement from Llama 2 to Llama 3. And Llama 4, I believe, is projected to come out this year. Let me make sure I got this correctly. Yes, to Llama 4. Do you expect 1 unit of growth from 3 to 4, like you had from 2 to 3? And then do you expect 1 unit of growth from 4 to 5? What do those fractions look like for the next 2 or 3 generations?
Okay, so I think, things are going to make progress because, you keep getting better at the engineering and collecting more data, et cetera. But we are going to see a real progress once we have an architecture that is demonstrated at scale that basically can reason with a mental model of the type I was telling you about. So when we think, when we plan, when we reason, we don't write every word that we think, and that would be kind of the current crop of compute time, of test time compute. Right? You write lots of words and then kind of select the ones that seem the best. This is not the way we reason. We reason in our mind. We have a mental model of the situation we're handling, and we are kind of planning a sequence of actions to arrive at a particular goal. I call this objective-driven AI. And so the technical challenges there is how do we train systems to have those mental models of the world. So there's another keyword now in AI research that you've seen, world models or action condition world models. So those are basically those type of models that would allow a system to plan and reason. They're not present in any of the current AI systems that are commercially deployed. But at the research level, a lot of people are working on this, particularly in the context of robotics, because you can't get around the problem of doing motion planning and things like that. So I think that's when, within a few years.
That's when you're excited about the next scaling. That's the next scaling you're excited about.
And that's what we're focusing on at FAIR, really. We're focusing on the next generation AI system that would be capable of understanding the physical world, have persistent memory, acquire some level of common sense, and be capable of planning and reasoning.
So let's talk about that next architecture, Jan. You've had many, many decades of being contrarian and right. and so you've argued now to abandon generative models. This is, again, the next architecture. To abandon probabilistic models, to abandon contrastive models, and to abandon much of reinforcement learning. So I know you mentioned it briefly, but at a very high level, what is objective-driven AI? What is JEPA? At a very high level.
Okay, so the basic principle that a lot of AI systems of today are based on is, or the paradigm it is based on, is self-supervised learning, something I've been also advocating for a decade, or even more. And it's based on the idea that you don't train the system to do any particular task other than basically predict missing information from the input, right? So an LLM, you take a piece of text and you train the system to predict the next word in the text. That's as simple as that. And it's amazing that by just doing this, the system learns how to produce language and even understand a lot of it. Now, the idea of using this in the context of the real world, so training a system to predict what's going to happen in a video, that has been around for a very long time. I've been working on this for the better part of 20 years. Because of this thought that if you're able to predict, you basically have constructed a mental model of reality. Now, for the better part of those 20 years, I worked on generative models. So the idea of basically, if I give you a segment of video, I stop it. And then I train a system to predict what's going to happen next. And maybe I give it an action that I think is going to happen in the video. Can the system predict what's going to happen next in the video? And that's basically been a complete failure. And the reason it's a failure is because you just cannot predict all the details that are happening in the real world. If I take a video of this part of the room and I slowly turn the camera and I stop it and I ask the system, can you predict the rest of the video? The system will predict, it's a meeting room and there's people sitting in chairs and stuff like that. There's no way the system can predict what every one of you looks like, right? It just can't come up with that, or the texture of the carpet, or the color of the lights, or whatever. There's just no way. The information is just not there. So predicting all the details in a video is what a generative model needs to do, okay? And this is what all the video prediction systems that people have been sort of making noise around are doing. They're trying to predict every detail in the video. This is bound to failure. So in the last 5 years, we've been working on a different type of architecture that is called JEPA. So that means Joint Embedding Predictive Architecture. And the idea of JEPA is you don't predict all the details. You basically train a system to learn an abstract representation of the video or the text or whatever it is, and then make prediction in that abstract representation space. And all the details that you cannot predict will be eliminated from that representation. So it makes the prediction problem much easier, and it drives the system towards basically learning the sort of relevant tidbits of information about the environment. So we've been working on this for a number of years now, and have systems that are now capable of doing some level of planning of actions and things like that in the real world. We have a paper we're just about to submit that shows those systems have acquired some sort of common sense, so they can tell you if something impossible happens in a video. So we're pretty
acquired
hopeful.
Some sense of common sense.
Some sort of common sense, yeah. There's an interesting calculation that I keep talking about. If you take the amount of information that big LLMs are trained on, that's roughly 20 trillion tokens. That's the amount of data that Llama 3, for example, has been trained on. It's all the publicly available text on the internet.
Which version of Llama does JEPA show up in? Which generation? Llama what?
If we're lucky, 5.
Llama 5. Wow, that's sooner than I would have thought.
If we're lucky. Okay, 20 trillion tokens. A token is 3 bytes, so that's 10 to the 13 bytes. Round this up to 10 to the 14 bytes. Okay, it would take us several 100,000 years to read through this. Okay, so it's an enormous amount of data. Now, put a number on how much information gets to the visual cortex of a child. In 4 years, a child has been awake a total of 16,000 hours. The optical nerve carry about 2 megabytes per second to the visual cortex. Do the math. In 4 years, a child has seen 10 to the 14 bytes in terms of visual information. And that tells you we're never going to get to human level AI by just training on text. It's just not going to happen.
So Jan, in prep for this session, as I mentioned earlier, I prompted ChatGPT, Gemini, and Meta for questions to ask Jan LeCun, and I prompted them for more controversial questions. I asked them for more timely questions. Only Gemini picked up on your work on JEPA. And Gemini had this question for you. So how do you envision overcoming the challenges of training and deploying energy-based models at scale, particularly in terms of compute resources and the availability of suitable databases?
Right, so this idea of energy-based model connects to what I was talking about earlier, which now people call test time compute. It's this idea that you compute the output of the system by optimization, right? You don't run through a fixed number of layers of a neural net, but you have some sort of objective function that measures to what extent a particular output of the system would satisfy or fulfill a goal, like win a game of chess or open this water bottle, whatever task you want. And then you have the system as an internal world model, and then figures out a sequence of actions that will satisfy the goal. And the sort of mathematical framework, if you want, to kind of explain how this works is what's called energy-based model. So you have an energy function that at runtime, at test time, is minimized with respect to the output that the system produces. Okay, so again, this idea of test time compute is not new at all. It's very classical.
So let's jump to the last question on JEPA. So Arvind at Perplexity, I believe you're an investor in Perplexity, if I recall correctly, on Lex Fridman applauded your many correct calls over the many decades. He, as an aside, mentioned that he didn't think JEPA was the right approach. He didn't specify why, but he mentioned that as an aside. What would you say to folks who may not be as bullish on JEPA as you are today?
Well, I think what he said was that he hasn't seen any demonstration yet that JEPA will constitute the next generation, the basis for the next generation AI system. He's right. I mean, we haven't built it yet, but it's coming soon. I mean, the way I've been sort of directing my research, over the last 40 years or so, is like, set yourself a very ambitious goal, and then figure out like what are the characteristics of a system that will eventually take you there, and then take the first step. And I tell you, I do not believe autoregressive LLMs are going to take us towards human level intelligence. I've been very vocal about this, okay? They're very useful. We should work on them. We have enormous teams at Meta who work on deploying them, and it's great, right? There's no issue with that. But as a path towards human level AI, they are kind of a distraction, a bit of an off-ramp. And so what you want is a system that is capable of doing this reasoning and planning and has some understanding of the physical world. And so it needs to have this at kind of the fundamental level.
And then a very basic question, when do we get to human level intelligence by your definition?
Well, so as I said in the first response to the first question, I don't see this happening, at least having a blueprint.
Thousands of days, would you say thousands of days?
Thousands of days, so what, how many thousands? I don't see this happening like having a blueprint for how to get there before 5 to 6 years, okay? And then it's going to take some more time to actually make this work. And it's always harder than we think. It's been sort of a repeated history over the history of AI that people have been sort of overly enthusiastic about the capabilities of a new technique they just came up with and turned out to be, disappointed.
Let's jump back to the near term, to 2025. Do you believe there's quite a bit of excitement, us included, of AI agents? Will 2025 be the year of AI agents? In our private summit 2 months ago, we asked 300 tech executives, what will 25 be the year of? And in the center of that word cloud was AI agents.
So AI agent is a problem. It's not a solution in the sense that everybody knows that we need to build systems that are capable of planning actions. Okay, and the question is how? And so I have my answer to this, which is, JEPA and energy-based models and world models and objective-driven AI. But
do you need all that for AI agents, or will AI agents that act autonomously on behalf of users, will that take off this year?
Okay, so we have two ways of making AI system take actions. The first one is the sort of long-term view that I just explained.
Yeah. Okay.
And then the shorter-term view is, how can we tweak our current paradigm so that it can do some sequences of actions, and that we can do like in certain areas. So first of all, we can train the system with lots and lots of existing plans, and then the system will be able to regurgitate and adapt existing plans, right? So you ask, plan a vacation in Costa Rica or something, and the thing will just give you a list of a circuit of all the interesting places, and it's because it's been trained to, with sufficient data to do that. It's not because it has a map of Costa Rica or anything. It's just that, it's been trained on sufficiently many plans, so it can regurgitate plans. Now, being able to plan from scratch, like zero shot, we need this next generation AI system. But you're going to see a lot of systems, like writing code requires planning. If the code is more than just, adapting an existing template, and people are working on this. Code is a particularly simple, or not simple, but appropriate area for agency, because you can check if it works, right? So the system can generate a piece of code and then run it and verifies that it generates data that makes sense.
Let me jump to open source. You and Meta are obviously very big proponents of open source. The question that I got from a colleague in my research was, have you seen an open source contribution to Llama that was both material and unexpected to Llama's development? And if so, kind of what is it? It's obviously one of the potential benefits of open source is unexpected and material improvements from folks who are not within the home of the developer.
Oh yeah, lots of them. So obviously a lot of applications where people take Llama and fine tune it for to speak certain languages, to answer certain questions. There is literally thousands of startups that basically are based on this model of taking Llama and then fine tuning it for a particular vertical application. I think we help create an entire industry with with Llama that enables this. Particularly for applications that require some level of privacy that you need to run on premise and things like this. So we see also through our partners a migration of even large companies from proprietary system to open source because they have more control. And then a lot of contributions that we've seen from the R&D community is on analyzing in what cases LLMs work and don't work, adding features like test time compute and planning and things like this. And then a lot of it also in optimization. So you can run systems on embedded hardware or super low precision arithmetics and things like that. So you can run it on sort of regular hardware without having gigantic GPUs.
On regulation, Jan, jumping to regulation, you've been very outspoken on regulation kind of over the years. One of the arguments has been that regulation should be at the application layer, not at the model layer. Do you believe that any regulation is appropriate for the model layer?
No. That's a very quick answer. No, I think, regulating R&D, how does that make any sense? The risk of regulating R&D is that you're going to tell the community you're taking a liability risk by releasing a model in open source. Most companies are not going to take that risk. Llama will basically disappear from one day to the next if there is any kind of cascading liability of, we can sue you because someone somewhere in the world has used, some customized version of Llama to do something bad and you're responsible. Like, no company would do this, right? Would release any open source model. Like, has anybody sued Linus Torvalds or the Linux Foundation for something bad that Linux did, okay? For some bug in Linux? No. If you're, I don't know, your Wi-Fi router, which runs Linux, has an issue and gets hacked or something, you're not suing Linus Torvalds. You're not even suing the Linux Foundation. You're suing the manufacturer of the box, okay? So regulation and liability for products that are deployed, yes. For open source platforms and research and development, absolutely not.
Yeah, and I'm going to end here with a lightning round. True or false, or other, and 20 seconds why. True or false, and then 20 seconds why. I envision a future where AI agents and humans coexist in virtual and physical settings.
True.
Why?
Every one of us would be running around with AI assistants within 10, 15 years. It might live in our smart glasses or things like that, and they will be with us at all times. There will be like a staff of people accompanying us at all times. It's like all of us would be like an executive in a large company with a staff of people following them. But they will be virtual people.
This is from Jensen from yesterday. The ChatGPT moment for general robotics is just around the corner.
It depends if you're myopic or not. Yeah, there is a corner that's going to be turned within the next few years, probably because of world model planning, things like that, which will enable the next generation robots. And we don't have it at the moment, but it will happen, and it might happen at the same time that robot manufacturers actually can build robots at a reasonable price.
That ChatGPT moment for general robotics is, you envision 2 years away, 3 years away, 5 years away, 10 years away?
I'd say 3 to 5.
True or false? 30 seconds, 20 seconds why. An AI agent will conduct and write research that is accepted by a technical conference such as NeurIPS within the next 5 years.
No, not without human direction, at least, and not at the level of a graduate student or anything like this.
Within the next 15 years.
Well, we're struggling with getting machines to be as smart as a cat, you're talking about a scientist here. Right?
No AI scientists, gotcha. Next one. Nuclear is the best and safest source to meet AI energy demand. True or false? 10 seconds why.
True, I've been saying this for a long time, too, yeah.
Second to last one. Your tweets are amazing. For 2025, your tweets towards the president-elect and towards Elon Musk will be a lot nicer.
Well,
I hear no's in the audience. I hear people saying no in the audience.
Okay, so I don't post on X anymore. Okay, I don't write I don't write substantive tweets anymore. I think it's basically a lost cause. And so I retweet, stuff that I find interesting. I occasionally make comments on posts by friends or people I know, and that's about it. And I don't write tweets. Okay.
Nice or true, false?
I post on Threads, on LinkedIn, on Facebook, and that's where you want to be. I haven't changed my political opinions, if that's the question. What really riled me up about Elon was his attack on the institutions of science. He's attacking scientists like Anthony Fauci and, telling people like, don't go to school, it's useless, and, universities are, have become woke or whatever. I mean, this it's just like, this idea of basically destroying the trust in institutions of higher learning and science, I think is extremely destructive. Also democracy, but that's a different story. So I haven't changed my opinion about this. And unfortunately, Elon hasn't either.
Well, Jan, we're out of time. Thank you for your tweets. Thank you for all the work you've done for many decades to get us to where we are. Thank you for your future work. Look at this room. This room is packed. So many, many thanks to Jan LeCun for being at CES.
Well, I'll tell you two things. He's wrong about robots. The robots are already here. If you have not seen the TV show Humans, watch it. Il est dans l'erreur avec les robots. Si vous n'avez jamais vu le TV show Humans, regardez ça, vous allez tout comprendre. Puis il défend les attention ça, viens voir moi, va voir ta serveur. Sorry. Il défend les universités, là, ce gars-là, je veux rien savoir. Mais c'est intéressant, par exemple, ce qu'il disait sur les agents. Si vous ne savez pas c'est quoi les agents, regardez la conférence de NVIDIA que j'ai faite. But I do agree with him, with these AI agent. If you have not seen the conference of NVIDIA, it's a must, okay? And I really believe what he said is true. That I agree with him, with the fact that people are gonna run around with the AI agent like they are executive, they're going to manage them. I do agree with that. Okay, so on that note, I'm gonna come back with my last keynote of the day. I'll be back in 5. See you there. Je reviens dans 5 minutes pour mon dernier keynote de la journée.